Hello everyone, my name is Al, and in this video I will mainly talk about the paper Particle-Based Viscoelastic Fluid Simulation. I will briefly explain the algorithm behind this paper and show you some interesting results in both 2D and 3D from my implementations of it. Fluids are the most common materials we can find in the world. However, the behavior of fluids can be very complex. And this is why simulating fluids is one of the hottest topics in research. There are two main categories of methods of fluid simulation in terms of the viewpoint, the Lagrangian methods and the Eulerian methods. And this paper I implemented belongs to the former one. This paper has three main characteristics. It simulates fluids as particle systems. Each particle represents a tiny portions of the fluid, and forces act between particle pairs are simulated using density-related functions. In addition, this paper aims for simulating fluid with viscosity and elasticity. This is achieved by adding springs between neighboring particles. Besides, the fluid can interact with a rigid body substance using an impulse-based solver. The algorithm has 8 steps. The first one is applying gravity to particles. This is done by modifying the velocity of particles. Step 2, 4, and 5 relate to adding the viscosity and elasticity properties to the particles. If any two particles are close enough, the algorithm would add a spring to the pair, which makes them hard to separate. The particle's position is updated by using its current velocity. Step 6 is to simulate the internal forces acting between particles due to pressure differences in fluid. And the density is approximated by summing weighted contributions from particles' neighbors. The pressure of the particle is proportional to the difference between the current density and the rest density. Besides the density, this paper introduces another context-dependent term named near pressure to prevent particle clustering. To resolve the collision between particles and rigid body, the algorithm calculates the impulse caused by the collision. The impulse is calculated by orthogonally decomposing the relative velocity of the particle and the rigid body. And the last step is to update the velocity of the particles by calculating the position differences between current step and the previous step. In this project, I implemented the 2D and the 3D versions of fluid simulation based on this paper. I also refers to the awesome book Fluid Simulations for Computer Graphics written by Robert Britson. The 2D version is written in Java with processing library, which provides convenient methods for drawing GUI. The 3D version extends on the 2D implementation. Instead of showing the GUI, the 3D implementation writes the positions of each particles for each frame into a file. The data is loaded to Blender using Python script, and the animation is rendered and generated using Blender. Here are some very cool 2D simulation results. By changing the viscosity and plasticity parameters, the behavior of the fluid is pretty different. As you may already notice, the GUI provides various parameters for users to play with. You can change the viscosity or plasticity parameters in real time to change the fluid's behavior. You can add fluid particles to the system, or you can add more rigid bodies if you want. You can also play with the gravity, either by reverting it or adjusting its scale. Here are some fluid animations using the 3D implementation with Blender.